Alright, welcome to our notes through 3.1. Let's go ahead and get started. So 3.1, sorry, let me arrange my windows here, is going to start talking about what we kind of refer to as summary statistics. Alright, so let's go ahead and dive in. Number one, just a one-off question. We don't like using the word average. We should use the term mean. And so there we go. It's just very early on, maybe a nice way of saying statisticians are very particular about wording, and I'm sure you figured that out through kind of those extra questions after you do the math of every question. Up next, I like this next question, and I want you to go through it yourself to figure out the answer. So we'll move on from there. And up next, it's time to figure out how to find the mean, median, and mode. So we're going to start by calling 3.1 summary statistics. And so, here we go. The first one is mean. Now the mean is, yes, it is just the average, but for some reason they say mean instead. Again, don't get me started about your textbook. I am not a fan. Now, this formula right here is our new mathematical definition or way of writing mean. It is, oops, let me get out of the math print. Oh my. There we go. It is the sum of all data points divided by the amount of data points. All right, I think we know how to find the mean, right? You add up everything and then divide by how many things you added, right? That's another way of saying it. Now, again, that's just the math way of writing it. That big Greek E is actually a Greek sigma, and it stands for sum, and it means take every single one of your data values and add them all up and then divide by how many there were. And the thing is, again, we have StatCrunch, so gone are the days of writing 48 plus 57 plus 94 in your calculator. We can just open up StatCrunch, and we can say that I just want some summary statistics on a column, right? Because this is a column, it's var1. And really everything here we're probably going to want anyways, so let's just go ahead and compute it. Right there, I can see the mean is 52.636. So let's hear 52.6 is one decimal place if I round it. There we go. Find the median. Now the median is a little bit different. It is the value between the lower 50% of data and upper 50% of data. We could go a step further. For odd amount of data, it's a single value. And for even amount of data, it's the average of the middle two. Right? Hopefully that sounds familiar. The way you find median is you literally order the data from least to greatest and look for the middle value. Now, thankfully, again, we have StatCrunch. You don't need to write these down one at a time and cross them out in order. You can go right here and look at the median. It's 48. Now, there were 11 data points here, so 48 is actually, where is it? It's that value right there. In fact, here, let's do this. We don't have to, but let's go ahead and sort it anyways, just to see. All right. Now it's sorted, and if I count from 1 to 11, if you think about it, there's 5 below, there's 5 above, and there's a 6th in the middle. And look, there's 48 right in the middle. So you can see that right there, just to say out loud, but it's also right there in your data. So there's the median, 48. All right. And let's see here. Maybe a new one, or no, not this time. The mode is the one that appears most frequently. So is there a value that appears more than once? Do I see any duplicates or triplicates or whatever? In this case, no, I actually don't see any data value that appears more than once, so there is no mode. They're all a tie. They all appear once. Now, if there is a tie, again, you write down all the ties, but since it's like literally everything's a tie for one value and there's no repetition, there is no mode. Now finally, the mid-range, this is a little bit different. And let's write that down as a definition. Whoops. Mid-range is the average of the least and greatest data point. So same thing. I've got my sorted data. I've got 23 and 95. If I just go ahead and average 23 and 95, that's two values that I add together, so I add them and then divide by 2. I get 59. Notice mid-range is not in this plot, so you will need to remember what that is. So the mid-range, again, I got 59. You're just averaging the lowest and the highest. And there we go. All right. What do the results tell us? Well, let's see here. These are 11 jersey numbers, and I alluded to this back in our chapter 2. Jersey numbers are what we call nominal. And what that means is, again, they don't measure or count anything. Your basketball jersey, 00, 99, 23, that doesn't have anything to do with how good you are. That's just another choice you have of what number do you want. And so it doesn't actually refer to your rank or how many points you score or how well you do. So there you go. Up next, let's see here. They again want us to find the mean, median, mode, mid-range, and then answer another question. Now the thing is, it's the highest net worth of salaries, highest amounts of net worth of all celebrities. What does it tell us about all celebrities? So in other words, their data's about the highest net worths, and then they want us to talk about all celebrities. So this will be an interesting one to go through just for that one little extra bit at the end there. Let's open this in StatCrunch. And let's look at some summary stats. Alright, my mean is 184.5. I know I'm doing that a little quick, but hopefully you're following along and pausing the video if you need to. Again, I just press summary stats, and then on columns, and I wanted the column to be var1 because that's the only column. That'll happen a lot, really. It's like you're choosing var1 almost all the time until we get to like chapters 8 and 9. The median is 170. The mode, let's see, do I have repetition this time? Looks like I've got 4 165s, so it looks like 165 would be my mode because it appeared 4 times, which is the most out of any of them. The mid-range, the average of the lowest and highest. Here we go. I have the min and the max right there, so 165 plus 285 divided by 2 is 225. So I've got 225 as my mid-range. And finally, what does it tell us about the population of all celebrities? Now, this is, again, I'm kind of just trying to help you out here, but apart from the fact that all other celebrities have lower net worths, nothing meaningful can be known about the population. I'll go ahead and tell you that sounds right, because just because you know about the highest net worths doesn't mean you know about all the net worths. So that sounds a little good. Let's see here. The next one, however, the result from Part C shows the most common celebrity net worth is equal to the mode. Now again, that's the most common highest celebrity net worth, so I don't agree with that statement. I still think it's A. The results tell us that all celebrities should have amounts of net worth. No, because we had the highest amounts of net worth. I think I'm going with A. And I mean, I knew the answer was A, but I kind of wanted to show you that one. So when you only talked about the highest net worth, or when you only have the highest net worth, you can't then generalize to all celebrities. You can only talk about the highest net worth celebrities. Also, take a look at these amounts. And I would say, since, once again, they appear to end in zeros and fives, they're probably rounded. All right, there we go. Up next, we've got another set of about 10 data points. They want mean, mid-range, median, mode. I'm going to skip over that one because, once again, you've got StatCrunch. I trust you can do it. Up next, you've got 2 different data sets. So maybe I was a little bit, too quick to say you wouldn't need two variables until chapter 8 and 9. You can still do summary stats. You can do it on columns. And I think we can even just highlight both columns. So one thing you can do is you can either hold your mouse down and click, or you can kind of press control click and grab them both. But take a look at this. It shows them both, one on top of the other. So you don't have to do this more than once. You can still choose more than one column at a time. And it looks like security was 1.48. And other companies is 2.04. And so you could proceed through the rest of the question like that. You can do more than one at a time. I'll let you go through that. All right, up next we have measures about the Richter scale. And let's see here. It says, is the magnitude of 7.0 an outlier? Interesting. Well, let's take this data. I like that question. Let's look at stats. Let's look at summary stats. And I've got a mean of 1.49. Oop, but they want 3 decimal places. 1.495. I've got a median of 1.51, which is a little bit annoying because they wanted 3 decimal places, but they only give me 2, but that works. All right, up next is the measure of 7.0, considered an outlier. Now, one thing to say there is, we haven't looked at this too much in depth, but you can see even Q3, if you think about it, the median is technically, we haven't quite gone over this yet, but the median is technically Q2, right? There's Q1, which is the bottom 25 from the upper 75. There's the median, which is the bottom 50 from the upper 50. There's Q3, which is the bottom 75 from the upper 25. And even so, Q3 is only 2.25. And again, we're about to learn a formula that's really precise and will tell us with certainty that yes, 7.0 is an outlier. But also, don't forget that we learned how to make histograms. And so if I take my var1 and I start at 0 and I have a width of 1, whoops, that's kind of interesting. Start at 0, width of 1. Where's my height of 7? Oh, there is no height of 7. Sorry, they're saying, would a height of 7 be? I thought it was in the data. Would a height of 7 be an outlier? We would say, oh, sorry, and you know what? I missed that in the summary stats because I missed that wording the first time. Sorry, let me get this. Column, compute. We already had a max. It was only 2.96. So would that be an outlier? Absolutely it'd be an outlier because it's way higher than even the max of the data. So sorry, I should have read a little bit further. That's what happens when you do this more than once. You start assuming what's going on rather than reading. Read carefully. Yes, because it's very far away from other data values. Okay. And at that point, honestly, we're done with summary statistics. So 3.1, honestly, might be one of the easier homeworks of the whole course. And let's look at 3.2. All right. So now, really quickly, we're going to call 3.2 measures of spread. So we're going to move from saying, what are my data values? What's my mean? What's my median? And we're going to start learning about how far do my values move from the center. And so, first thing is we're going to say, with data, we're going to say this. We're going to go back to lower fences and upper fences. And we're going to use some new mathematical symbolism here. And we're going to say my lower fence could be, watch this, my mean minus 2 standard deviations. I know that I'm writing that with very interesting letters there. My upper fence could be my mean plus 2 standard deviations. So I just introduced some new terminology for you. And remember, if a data point is outside of lower or upper fences, it is significant or rare. Alright, so we just learned a way of determining if points are significantly low or significantly high. We found some cutoff values. It's my mean. Now, we haven't defined this symbol super formally yet, but this symbol's called mu. It stands for your population mean. We'll have a page of that somewhere in the notes at some point. And then we have this sigma, which is our population standard deviation, which is a word we haven't totally defined yet, but that's okay. We're going through the homework as it comes to us, and so here we go. They call this the range rule of thumb, but it's this lower fence, upper fence idea. And again, we're starting from a middle point, right? Some sort of middle, our mean, and we're either subtracting 2 standard deviations or adding 2 standard deviations. So 2 standard deviations away. That should be a little interesting. You might want to look back at our chapter 2 notes and look at that normal distribution and think about what it means to be below 2 standard deviations or above 2, but don't worry, we'll probably be looking at that again in 5 minutes in these videos together. So let's see here. If I want to find significantly low or significantly high values, I would take my mean, which is, right, it says right here, 1062.1, and I would subtract 2 standard deviations. So I'm literally typing 1062.1 minus 2 times 120.4 in my calculator, and I'm getting 821.3. There we go. And all I have to do now is kind of recopy that text in my calculator and just change the minus to a plus, and I now get 1302.9. And there we go. And now the question is this significantly high? Well, no, because it's within my fences, right? There's my low, there's my high, this is in between. So no, because it's between the limits of my separating values. Great, not too bad there. We just learned about, again, what we call the range rule of thumb. Uh-oh. Well, I'm having a hard time stopping the video. Well, you know what? No, we'll just press on. But man, I hate it when that pause button hides from me. Okay, anyways, let's see here. We have a standard deviation. What's a variance? Oh gosh, they're already asking that question. So it's time to spend some time on the page talking about what is standard deviation. Now, first, we should maybe write out the formal formula, which is a little bit ugly, I'm not going to lie. And the formula for standard deviation is a big old square root with some parentheses inside. Whoops. And there's also a big summation. It's every data point minus the mean squared all over n minus 1. So, few things to note here. Number one, this is another way of saying, whoops, mu, this symbol that kind of looks like a U or an M, depending on how you think about it. And the good news is it's mu. It's literally mu in the Greek. So did you think it was an M or a U? You're right on both accounts. It's mu. It stands for population mean. So remember, mean, already we saw this Greek E, which means add everything up, and then an N and divide by everything. So there's almost a shadow of that in here, but we're pushing that a lot. We're saying after you find the mean of all your data points, go ahead and take each point, compare it to the mean, and square that value. Add up all of those. Now, we'll do that in one example here just to write out what we did, and then divide it by n minus 1. Now, if we can put a definition on this, which is kind of tough to do, but we could say the standard deviation is the average distance or deviation of each data point to the mean of all the data points. Deviation. There we go. All right, that's why we call it a deviation. A deviation is just another way of saying difference or subtraction from. So, hey, look, each point subtracted from the mean. Now we're squaring that distance for reasons, and we're putting this whole thing in a square root for reasons we don't have time to talk about in this class, other than just to say we square it because it penalizes larger distances from the mean. It makes them hurt more. It makes the deviation have more weight to it than just doing maybe like an absolute value away. You know, what's your raw distance? Is it 2, 3, or 5? Well, no, we want to square that and say it's 4, 9, or 25 instead. Penalize those further distances, make them count for more by squaring them. But then square root the whole thing at the end, because after all, we shouldn't be squaring the units in the first place, but we do. Again, you can ask mathematic professors why we use that formula, and they could talk to you a lot more about it, and we don't need to worry about it, but just know that's why it exists. We square to penalize the distances that are further, but we square root to get back to essentially the same unit that we started with, and that's a good thing for you to know. Now then, of course, we have to define what variance is. Variance is used in a lot further statistical classes, but all you need to know is it's just your standard deviation squared. So I'll even just write it like that. Whatever your standard deviation is, square it. Now you have your variance. So look, when they tell me that my standard deviation is 12.4533, guess what? I just square it, and I get 155.08468, which would round to 0.47 once I'm rounding to 4 decimal places. And since I squared it, I'm no longer in kilograms, I'm in kilograms squared. Now, in other words, to kind of say what I was saying before, is your variance is what you get before you take that final square root, just to say that out loud. So if you square this thing, you're eliminating the square root on the other side, so you're changing what unit you're measuring. And just to say that. All right, up next, I said we were going to maybe cover it, but hey, it's right here in the notes. Sample standard deviation, we just use the lowercase s. Population standard deviation, we use this sigma that we wrote down. Sample variance, well, that would be the s squared. Population variance would be the sigma squared. And there we go. So we just learned those symbols together in the homework. The unit for standard deviation, let's see here. If we were using weights in grams, would be grams. The unit for the population standard deviation would also be grams. Variance would be grams squared, and variance would be grams squared. So the thing we're trying to say here, and maybe this is the nice page to have it written in, is that because usually we weigh things in, grams, single grams, and then if we were to find the mean, that would be in grams, we want to make sure that our standard deviation is the same unit as what we're measuring in general. And so that's why we square root at the end, so that we don't end up with grams squared as a measurement. We end up with grams just like the mean or average would be in grams as well. Okay. Up next, now they say find the range, variance, and standard deviation. And, maybe we'll do another kind of extra video, quick example of how to find the standard deviation by hand. But hey, guess what? We have StatCrunch again in this class. It's the biggest blessing to this whole course. So let's look at summary stats, and let's see here. It looks like we already have all that in here already. We have the standard deviation and the range. Range is 81. Now remember, the range is literally the difference from the lowest to the highest. It's the difference between the min and max, so if you subtract those two, you get 81. Up next, the standard deviation. There it is, 23.956. 23.956. But they wanted 956, so careful, that would round up all the way to 24. Sample variance, well, it says variance right there, 573.89. 573.89 would round to 0.9. And there we go. So again, it's super nice that we have StatCrunch. It literally gives you all three, the variance, standard deviation, and the range, all in one without doing any work. Awesome. Once again, we talked about Jersey numbers, so we'll skip that for now. All right. This one again is going to ask you about, let's see here, range, variance, standard deviation, and then they're going to ask about all celebrities. Be careful because we already talked about that before. Up next, again, they're going to ask us about range, variance, standard deviation, and you have StatCrunch to do all of this. So, once again, range, variance, standard deviation. Do we have anything else? Another significantly low, significantly high. They want range rule of thumb. Remember that that's -2 standard deviations and +2 standard deviations. I think you can do that. And let's see here. Actually, this is kind of a good stopping place for the moment. We'll stop in the middle of 3.2. We're halfway done with the whole chapter. And so we'll finish up 3.2 and do 3.3 in the next video.